Today, in the middle of the afternoon, the sky over parts of Europe is going dark. Not because of a storm. Not because someone hit a dimmer switch on the planet. It's because the moon is sliding directly between the Earth and the Sun, and for a few minutes, day is turning into night in a handful of very specific places. This is the first time a total solar eclipse has crossed mainland Europe in 27 years, and NASA is putting together full live coverage for it. So let's talk about exactly what's happening, who gets to see it, and why there's a research plane chasing a shadow across the ocean right now to study it. What actually happens on Eclipse Day? Here's the basic setup. On Wednesday, August 12, 2026, a total solar eclipse is tracing a narrow path starting in remote Siberian Russia, arcing up over the North Pole, dropping down across eastern Greenland, clipping the western edge of Iceland, crossing the Atlantic Ocean, and finally sweeping through northern Spain and a small slice of Portugal before it ends near the Balearic Islands. That's the path of totality. If you're standing anywhere inside that narrow strip, for a brief window the moon completely blocks the sun and the sky genuinely goes dark in daytime. Outside that narrow path, a much wider chunk of the Northern Hemisphere gets a partial eclipse instead, where the moon only covers part of the sun. That includes parts of the US, most of Canada, a large part of Europe, and northwestern Africa. So even if you're not in Iceland or Spain, there's a real chance you can step outside and see a bite taken out of the sun today. Now here's a detail that makes this eclipse a little unusual. Because the path crosses so many time zones and loops over the pole, totality reaches different parts of the world at very different local times. In a remote part of northern Russia, totality actually happens around midday, right in the middle of the local afternoon, not at night. From there, the moon's shadow races west. By the time it reaches Greenland and Iceland, it's late afternoon or early evening local time, and by the time it reaches Spain and the tip of Portugal, the sun is already low, close to the horizon, in the late evening, shortly before sunset. So this single eclipse plays out very differently depending on where you're standing: midday in Russia, evening light in Iceland, and a sunset spectacle in Spain. Where and when to actually watch it? If you want the exact numbers, here they are. NASA's broadcast begins at 1:15 p.m. Eastern Time. Totality starts in Iceland around 1:45 p.m. Eastern, and in Spain around 2:28 p.m. Eastern. In local time, the moon's shadow first touches land in Iceland's westfords in the late afternoon, and totality there lasts a little over a minute in some spots and closer to 2 minutes near the coast. The longest totality anywhere on this eclipse's path is 2 minutes and 18 seconds, and that peak moment happens out over open ocean between Greenland and Iceland, so most people won't be standing in that exact spot. Still, if you're in Iceland near the centerline, you're looking at close to that number. In Spain, this is an even bigger deal, because the last time mainland Spain saw a total solar eclipse was in 1905. That's over a century ago. The path this time cuts across the country from west to east, passing near cities including Leon, Burgos, Valladolid, Zaragoza, Teruel, and Valencia, before wrapping up near the Balearic Islands. Because Spain sits toward the far end of the eclipse's path, the sun will already be low near the horizon when totality happens there. Picture the sun getting swallowed by the moon right as it's setting, with the sky shifting through shades of orange and deep blue at the same time. That's the kind of moment photographers plan entire trips around. And here's a fun coincidence worth sitting with. This eclipse happens just hours before the Perseid meteor shower reaches its peak overnight. The peak falls in the hours after midnight into August 13th, once the sky is fully dark. The moon is also new that day, which means no moonlight will wash out the night sky. So it's not that you'll see meteors during the brief daytime darkness of totality. That's not really something to expect, but if you stay up, or wake up early, after the eclipse, you're looking at one of the best meteor watching nights of the year, under a moon-free sky. If you're not anywhere near Iceland or Spain, don't count yourself out yet. People across parts of the US, most of Canada, a huge stretch of Europe, and parts of northwestern Africa will still get a partial eclipse today. So even a quick look outside in the afternoon could show you the moon taking a bite out of the sun, no flight required. Why NASA is sending a jet after a shadow? This is the part that surprised me a little. NASA isn't just pointing cameras at the sky and calling it coverage. During the eclipse, a NASA-funded science team is chasing the moon's shadow using a WB-57 high-altitude research aircraft, specifically to study the dynamics of the sun's corona, which is that faint glowing outer atmosphere you can only really see clearly when the sun's main disk is blocked out. On top of that, there's a program called the Nationwide Eclipse Ballooning Project, and it's sending student teams from several U.S. universities to Iceland and Spain to launch scientific balloons before, during, and after the eclipse. The goal is to measure how the sudden darkening of the sky affects Earth's atmosphere in real time. So while most of us are just looking up with a pair of eclipse glasses, there are literally teams of scientists flying planes and launching balloons into the same sky, trying to squeeze real data out of a few minutes of darkness. Ask yourself this for a second: if you had 2.5 minutes where the sky just went dark and the temperature dropped, what would you actually want to know about it? How to actually watch the coverage. NASA's live stream covers the entire path, with real views from across the eclipse route plus interviews with scientists explaining what's happening as it happens. You can catch that through nasa.gov/live. During the broadcast, NASA experts are also answering questions people send in through social media, so if you're watching along, you can actually get something answered live instead of just watching passively. And once it's over, NASA will be posting photos from across the path on their Flickr account, depending on how the weather cooperates in each location. Speaking of weather, that's really the only wild card here. Clear skies make or break an eclipse experience. Iceland's weather in August tends to cooperate reasonably well, and Spain in summer generally has decent odds of clear skies too, but nothing is guaranteed. That's part of why so many eclipse chasers plan multiple viewing spots along the path, so if clouds roll in over one location, they can still catch it somewhere else along that same line. Why this one actually matters. Total solar eclipses aren't rare on Earth as a whole, there's roughly one every year or two somewhere on the planet, but they're extremely rare for any one specific location. Iceland hasn't had a total solar eclipse since 1954, and the next one visible there isn't due until the year 2196. Spain's wait was even longer, over 120 years since 1905. So if you happen to live in or near the path this time, this genuinely might be a once-in-a-lifetime, or once-in-several-lifetimes, kind of moment. And that's really the whole reason NASA builds out this level of live coverage for something that technically lasts less than 3 minutes at its longest. It's not really about the 3 minutes. It's about everything leading up to it, and how differently that same 3 minutes looks depending on exactly where on Earth you're standing when it happens. If you're watching in person, remember the basic safety rule: you need proper eclipse glasses or a certified solar filter for every part of the eclipse except the brief seconds of full totality, when the sun's disk is completely covered. That's the only moment it's actually safe to look directly at it with your bare eyes. So here's a question worth sitting with today: if the sky went dark for 2 minutes right where you live, what would you even do with that time? Would you be watching the sky, or would you be watching everyone else's reaction to it? If this kind of space coverage is the sort of thing you want more of, you know exactly where the subscribe button lives, and hitting it means you won't miss whatever we cover next on this. Drop where you're watching this eclipse from in the comments, path of totality or partial view, either way I want to know. Because the next time the sky over Iceland goes fully dark in the daytime, most of us watching this video won't be around to see it.